Alright, in this video we're going to do another example of sketching a polar curve and then also finding the area bounded by that polar curve. So we're looking at another rose petal here. This is going to be, this one has 4 petals because of the 2 thetas, so you'll double the 2 to get the 4. And so we'll do this similar to how we did the last video. So the first thing we're going to do is we're just going to graph 2 cosine 2 theta like we would in pre-cal or in a trigonometry class. But I want to rig it so that I get the nice pole values for my theta. So I want 2 theta to be equal to those nice values. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. And dividing that by 2, we'll have theta is equal to 0, pi over 4, 3 pi over 4, pi over 2, and then 3 pi over 4, and then pi. And so when we set up our table, those will be the nice values. You can always verify in your calculator if you like, but these are going to work out nicely. So that's going to give us 2, 0, minus 2, 0, and 2. And we'll go ahead and graph that down here. I'm going to also include negative pi over 4, and you may want to leave a little bit to the left-hand side, and that's going to help us with the limits of integration. So we're just going to continue the curve a little bit to the left there, and that'll help us with that limit of integration a little bit here. Okay, so we're just going to put that stuff in there, and we're going to graph our cosine. So amplitude is 2, and then the period's only going to take pi, so we'll plot those points. Alright, so there's our graph. Okay, and then we'll go ahead and grab a polar coordinate system, and we're gonna find where the petal points are, and the petal points are going to be at mins or maxes of the graph here. So we'll have one at 0, 1 at pi over 2, but it's going to be directed down to 3 pi over 2 because it's negative, and then 1 at pi. Now, we said there was 4 petals. I only have 3 mins or maxes. What I need to do is I need to extend my graph. There's other ways of doing this. We're going to try to keep it simple by keeping it related to the trig graph here. So I'm going to go ahead and choose the scale to be, this is a radius 1, there's radius 2. And so we'll install the first point, 0 radians, we're out 2 units. And then so what originally happened is at pi over 2, we'd be up at 2. However, so we'd be up here. However, because it's negative, it's going to actually send us down that way. So I'm going to be down there. Can't make these dots go away for some reason. There we go. So there's 2 of them. Now we'll put the one up at pi. Okay. And I'm going to go ahead and extend my graph. My increased pi is pi over 4, so we'll go out a little further, and that'll give us that last petal point we're going to need. Now it's going to be at 3 pi over 2. So originally 3 pi over 2 would be down here. However, because it's negative down here, that's going to send it up there. So the directed distance is going to go the opposite direction. Okay, so we got our petal points. The next thing we can do to kind of help guide us is we'll assume that these are the tangent lines, and then I'll show you that they are the tangent lines at the end of the video. But we want to know where we cross the pole. Okay, so we're going to set our function equal to 0, and that's going to find where we cross the pole. So 2 cosine of 2 theta is equal to 0. That's going to happen when 2 cosine of theta is equal to 0, and cosine is equal to 0 at pi over 2 and 3 pi over 2 and 5 pi over 2 and 7 pi over 2 and negative pi over 2, so the north and the south poles. But that's when the angle is equal to that. So the angle here is 2 theta. So when is 2 theta equal to pi over 2 and 3 pi over 2 and 5 pi over 2 and 7 pi over 2? And if I need to go further or in the negative direction, I can. So that's going to give us theta is equal to pi over 4 and 3 pi over 4, and 5 pi over 4, and 7 pi over 4. Okay. Now in this unit, this polar coordinate system that I grabbed doesn't have those pi over 4s, the 45 degrees labels. We can label them. So here's pi over 4. Over here would be the 3 pi over 4, 5 pi over 4, and 7 pi over 4. So notice what's going to happen is pi over 4 and 5 pi over 4 are actually on the same radial line, and 3 pi over 4 and 7 pi over 4 are on the same radial line. So we only have potentially, and we're going to go ahead and assume that we have 2 tangents here. Okay. All right. It looks like part of the graph got snuck in there. So we're going to graph the first part, which is going to start here. Okay. And then we're going to curve back down to 0 as we approach pi over 4. So you see we have this curve here. Okay. Then this whole portion down here, this is all negative. Okay. So that means it's going to be reflected. So that is pi over 4 to 3 pi over 4. So this portion here, that's going to be reflected in there. This portion here, that's going to be reflected down there. So we're gonna have a rose curve like that. Okay. So there it is. And the next part we'll sketch is from 3 pi over 4 to 5 pi over 4. It's all positive, so it's gonna behave nicely. It's not gonna be reflected, so it's gonna go like this. Okay. And you see that I'm kind of flattening them out there. I'm trying to do that. It's kind of hard, but that's where you have your horizontal tangent. So I'm trying to make it a little bit flat. You know, if you want a real nice rose curve, use Desmos. All right, and we're to the last portion here. The 5 pi over 4 to 3 pi over 2. That's going to be negative. So that's this portion right here. So this portion here, that's going to be reflected up there, and then this portion here, that's going to be reflected there. So we'll start over here, and we'll do something like that. Okay. All right. And there we are. And now we finished the whole cycle, so we're almost done with the full cycle here. And then to finish it off here, it's going to come back up like this. And this portion right here can be represented by this part here, the negative pi over 4 to 0 here. Okay. So we'll finish off our rose curve. Okay. Now the part I'm highlighting in orange, that's from negative pi over 4 to pi over 4. So that's going to actually give us one of our rose petals, and that's what we're looking for. So we just want to get one of them. We got nice bounds. So probably the easiest limits of integration is to do negative pi over 4 to pi over 4. Another one we could do is 7 pi over 4 to not pi over 4, because if we follow the order, it would be 7 pi over 4 and then 2 pi, 9 pi over 4. So we do 7 pi over 4 to 9 pi over 4. That would be another possibility, but we'll use the negative pi over 4 to pi over 4. Okay. So that was what we were doing here. We were practicing graphing the rose curve, and then we also got our limits of integration. So now we're ready to go ahead and integrate this thing. We'll have to use that power reducing formula that I used on the previous video. That power reducing formula we used was the cosine squared of theta is equal to 1 plus cosine of 2 theta over 2. So we're going to use that on the next slide here. So there's 4 petals, so it's going to be 4, and then it's a 1/2 out in front, so 4 over 2, negative pi over 4 to pi over 4, 2 cosine 2 theta squared d theta. Okay. So the 2 squared will be 4, times the 4 on the outside here will be 16 divided by 2, that gives us 8. So we got negative pi over 4 to pi over 4. of cosine squared of 2 theta d theta. We'll use the power reducing formula. And the power reducing formula is going to introduce a 1/2, and 1/2 of 8 is 4. Negative pi over 4 to pi over 4 of 1 plus cosine double the angle will become 4 theta d theta. And we'll go ahead and integrate it, so it's going to be 4 theta plus sine of 4 theta divided by 4, evaluated from negative pi over 4 to pi over 4. Now, similar to the last example, when I plug in pi over, let's not do that. Let's negative pi over 4 and pi over 4 into the 4 theta. That's going to give me negative pi and pi, both of which are 0 when we take the sine of them. So we don't really need to worry about the sine portion. We just need to evaluate at pi. So we'll do that. So we'll have 4, and then it'll be pi over 4 minus your lower limit of negative pi over 4, and that'll simplify down to 2 pi, and that's the area of the region bounded by this rose curve.